Okay, there we go. Are you able to see everything cleanly if I do that as well? All right, cool.
Yeah.
So I'll be talking about boosting your data team's productivity. Let's see, with Explorer. So just a quick introduction. We've had a little chat already. I am the co-founder and CTO at a company called Amplified AI. We're a knowledge platform for patents, intellectual property innovation. And what that means at a high level is basically that we take all the patents in the world, we map them into vector representations, and then we do a lot of stuff with that. We make all the information that's available in like global patent data manageable. We give you the ability to search it very easily, to do things like build classifiers, to visualize it, to understand your own portfolio, all those sorts of things. That came out of my PhD work. I was an innovation economist working on environmental economics, innovation economics, climate policy. And I was trying to figure out ways of representing all of this vast patent information in a numerical format that I could plug into econometric models, so statistical economic models. And I then started a company. I met a guy who worked in innovation consulting. He had some ideas about the ways that machine learning could start to change the way that people worked in that field. We got to chatting, and this was probably, 2014 we chatted for the first time, and then we founded the company in late 2016, early 2017, and actually incorporated in 2017. So we've been at it for a little while. A little bit more about me. I'm the father to one human and one cat. we talked about the human and not the cat. The cat is also important. And I'm the original author of Explorer. I say original, as I said before, because it's mostly out of my hands now. We have a few people who have kind of joined on and are really kind of carrying the torch with that. And I say data scientist with a question mark. And that's going to kind of lead into what we're going to talk about at first. I'm going to take you through a few things. You might wonder, what does this all have to do with it? But it's quite important, I think, for understanding how Explorer can help you and your kind of data science needs. So what is data science? This is the question that we're always asked, right? If you're a data scientist, if you're working in data science, people are like, well, what is it? It sounds maybe obvious on the face of it, or maybe really confusing on the face of it, depending on where you come from. A lot of different opinions, right? So some people say it's, one of these. It's, you've got computer science and math and domain knowledge, and all together it's data science, and there's some other stuff in between. Some people, kind of describe it this way and say you're a unicorn, you don't really exist. Other people have these much larger kind of sets of definitions, saying you've got to have hacking skills and social science knowledge and stats knowledge and all of this sort of stuff. And it just gets more and more complex, right? Like many people have many opinions on what data science is. But I'm going to say that data science is a process. And I think that that's really fundamental to what we're going to talk about. So data science is basically this process. And this comes from R for data science. Basically, you get some data, you import it into whatever environment you're working in, you tidy that data into a format or an organized state that you can work with it. And then you start to iterate. You do some transformations, you do some visualizations, you maybe do some modeling, and then you go back and transform based on what you've learned, right? And you kind of go through this process over and over and over again. And then at the end, you're going to want to communicate what you've learned from that. It really needs to be an iterative, kind of cyclical process, right? So it can also look like this if you're going from left to right. Those cyclical aspects kind of are built in here. But what this shows is a little bit more of a mapping of how different parts might be taken by different people within your business. So data engineers over with collection and cleaning, data analysts do the cleaning and exploratory side of things, and then machine learning engineers, if you're really specialized, start doing the model building, the model deployment. And if you are a data scientist, you're expected to do basically all of it, right? Now, so the thing about that is that let's go back for a second. You see, okay, it looks nicely evenly separated into 5 different parts, right? But it's regularly said 80% or more of the time that you spend as a data practitioner, as a data scientist or whatever, is spent finding, cleaning, and organizing data. This is really fundamental, and anybody here who has worked in this as their kind of day job knows that like most of the work that you're doing is data. It's grueling. You're just working through it, and you deal with data that is ugly and misaligned and has, you know, random capitals over here, and it's in snake case over here, and somebody has just dumped something over there. It's all nasty, and you need to get it into a format and into a place where you can actually learn something from it, right? It's your most valuable asset, and usually it's barely an asset at all when it gets into your hands. So I'll extend what I said before and say that data science is not just a process, but data science is a process that is greatly improved with a thing called tidy data. So what is tidy data? So it's a paper published by Hadley Wickham. Hadley Wickham is kind of the golden god of the R community. He is the inventor of the tidyverse. He wrote this really, really influential paper on the concepts of tidy data. And it's mostly around the ways that we can kind of have a structured and formal understanding of what well-structured data is, so that we can work with it in a consistent way and learn from it. This is really close to some of your relational database theory, but it works slightly differently and has some statistical definitions pinned onto it. So he describes it as this: tidy data is a standard way of mapping the meaning of a data set to its structure. So there's the key there, the word that's doing a lot of work in that sentence is standard. A data set is messy or tidy. So those are the two kind of things that we're working with. We can say that it's tidy or it's messy, depending on how rows, columns, and tables are matched up with observations, variables, and types. As I said before, that there's some statistical knowledge here, some statistical understanding of what we mean when we're talking about this. It's not just about the tabular format. It's also to do with how those map onto our real world observations, right? I found this really fun. So Leo Tolstoy says, I think it was in War and Peace, happy families are all alike. Every unhappy family is unhappy in its own way, right? And Hadley Wickham says, tidy data sets are all alike, but every messy data set is messy in its own way. And this is really true. So the goal of that first major step that you take, the thing that often takes 80% of your time, is collecting data and getting it into what should be a tidy format. And then once you have it in that tidy format, then you can start to do stuff with it. So you want to try to get it to be all alike with all the other stuff, right? But in order to get there, you have to work with an infinite kind of variety of what messy data can be. So let's just formalize this a little bit more. So what is tidy data? We say that each variable from a statistical sense forms a column in a data sense. So each observation in a statistical sense forms a row in a data sense. So we think about it as a tabular data set. We think about relational databases that have columns and rows, right? And each type of observational unit forms a table. And that's really, really important as well. You see a lot of like denormalized data. And one of the things that struck me as an economist was seeing so many people working with like Stata and MATLAB and things like that, and trying to stuff everything into like one big table because they didn't really understand this notion of tidy data, and getting all the different observable units, the observational units, forming separate tables. It's a really pivotal point here. So, and then we say that messy data is any other arrangement of the data, right? So we can have an example. This is some messy data. You can see we've got this where the rows have names. The rows are actually the names of the people, and the columns have these names here, treatment A and treatment B. And then we've got some observations where they intersect. And this is a perfectly reasonable way of thinking about data, right? It's really common for people to say, okay, well, we've got tables, and we've got rows and columns, and we think that the values are going to be in the cells, and then we're going to name each of the rows and name each of the columns, and where they intersect, perfectly reasonable. It's like when you look at a grid, like on a map, right? You want to find the way that the places they intersect. It makes sense. Unfortunately, it's very, very difficult to work with. The second one here is basically the same thing, just structured another way. So it's just inverted so that the names are the columns and the treatments are the row names. This is the tidy way of representing that data. So here we've got each column is a variable. Each one is a person, right? Person, treatment, result. And then each row is an observation. So when you've got John Smith has treatment A, we have a missing result. Jane Doe has treatment A, we have a result of 16. We can see how we're able to kind of work with this in a bit more of a structured way. We'll get to a little bit more of that a little bit later. So just to list some of the common problems that you might see, like where we said what we saw a minute ago, column headers are values, not variable names, where multiple variables might be stored in one column. Very, very common for people to try to do this. Variables are stored in both rows and columns. That gets very, very confusing. You might get multiple types of observational units all in the same table. I mentioned that before, or a single observational unit might be stored in multiple tables. It might be split across multiple tables. I'm kind of giving you the background and the theory right now. We'll get into a little bit of the practice later, so I don't want you to worry too much if it's going quickly. Here's another example of untidy data, messy data. You can see here that we've got a variable, right? Like we've got a value that's basically determining the column names here. We can just switch that over here. So we've got religion as a column, income as a column, and frequency as a column. And this is a tidy data set. Okay, so why should you care about this tidy data? Why does it matter? And the two main reasons are that it's easier for computers and humans to understand when it's tidy and consistent format permits consistent tools. And this is what kind of pulled me into this and got me a bit excited about it. So with R, you have this thing called the tidyverse, right? Which is it's a combination of tidy data, and universe. It's probably self-explanatory, but it's worth spelling it out. And if you've ever worked with it before, you'll know that it's a very opinionated collection of R libraries. Everything there assumes that you have organized your data in a tidy way. And what that allows is for you to basically just really readily pass data between all these different libraries. So you can kind of see here, we've got, we've got like readr, which is a library for fast reading of tabular data, and tibble is a data structure that's like a fast data structure for tables. Basically, what you'll find with tidyverse and with the R kind of community generally is that what they've basically done is re-implemented a lot of the kind of base constructs in R in faster, RCPP, which is R C++ libraries. And they conform more to these tidy data and tidy can put together, these tidy principles and ideas. So tidyr is a library for basically moving data from like what you might call a pivot. There's purr, which is functional data and functional data manipulation. dflyer, which is kind of where you're working with the tables, and this is the closest thing to Explorer. stringr for working for strings, forcats for working categories. ggplot2 is like kind of the famous visualization library in R. It's what basically everyone else tries to do and really struggles with. It's built on a thing called the grammar of graphics, which Vega Lite is actually influenced by and builds on as well. So we'll get to that a little bit later. But these principles are really important. Like, it's human-centered design. So it's not just that it works better with machines. As I mentioned before, humans can understand this a lot more simply. It's consistent, and they're composable, which is what I was saying a moment ago. You can stack them on top of each other. They work well together, and they care about inclusivity. It's just one of their principles. So you might be thinking, hey, I thought I was going to talk about Elixir. Why are you telling me? Why are you here preaching about tidy data, right? So let's talk about Explorer. So let's take those principles that we just talked about a second ago, tidy data, and let's talk about the design principles of Explorer and the things that influenced me when I was originally designing it. So we constrain your options. And by constraining your options, we help you think about your data manipulation challenges. When you have less of a surface area, less of an API surface to think about, you can immediately start to translate your thought into code, right? And part of what does that as well is that we provide simple verbs. So you'll see what those verbs are in a moment. We'll kind of talk about them, but basically they're functions that correspond to really common data manipulation tasks, things like filter, select, and they help you translate your thoughts into code. Again, the idea is to give you a language so that you can take the language that you're thinking in terms of how you want to manipulate your data, the functional pipeline that you want to take, and translate that into code so that you can the most quickly possible get the insights that you're after. And it uses efficient backends, so you spend less time waiting for your computer. As I mentioned before, we use Polars as a backend. It's the only backend right now, but Explorer was actually designed in a similar way to how NX was designed, which is that it's a behavior, and it's a behavior that many different backends could fulfill. So you could theoretically, you could write a pandas backend for Explorer. If you could work with the interop, you could build a SQL backend. So you could do an Ecto backend for Explorer. And we've explored some of these other options. Haven't gotten there yet, but there are really promising potential routes for implementing different backends for Explorer. But so the thing about this is, just so you kind of see how closely this maps, this text was actually taken from the dplyr documentation. So literally mapped directly onto Explorer. This text isn't written for Explorer. So the idea there was that we wanted to have the elegance of dplyr, which is really wonderful, the speed of Polars, which we mentioned earlier on, and the joy of Elixir, because I think that Elixir is one of the most fun and intuitive and readable programming languages out there. People often say that it's a superpower, right? So just quickly, we'll touch on Polars. I think some of you guys are familiar with it, but it's a Rust-based data frame library. They've actually spun it off into a company, and strangely enough, they're in the Netherlands as well. I haven't gone and met Richie, but he's based in Utrecht. And they kind of started making a splash a couple of years ago, about 2.5 years ago or so, with just how fast it was. So it wasn't just that it was Rust, it was that they were using some of the best kind of algorithms out there, and really pushing the envelope for what could be achieved in a data frame library. And so building on top of that, we actually have a lot of performance to spare. So when I talk about the joy of Elixir, and I talk about the elegance of dplyr, and the speed and power of Polars, it's kind of it sounds very like kind of fluffy, right? So let's look at it in practice. So here's pandas, and I will rag on pandas a lot. I know that some people like pandas, and those people are wrong. Just kidding, but it's basically I
You're
find
like Linus Torvalds, Linus Torvalds with his opinions.
Yeah, exactly. It's my opinion, and it's your opinion too. Yeah, basically, like I know what this means. I wrote this, like I know how to, this is formatted with black. It's the way it's supposed to be. I can see that I'm doing this kind of like dot chaining. Like I've got group by, I've got the by argument there. I wrote this a couple of years ago, so it's changed a little bit, but it's still a hunk of text, right? It's kind of a hunk of text. There are different ways of doing this, for sure. Really confusing to me the way that filter works, because it's not actually filtering rows, it's doing columns. But yes, I find this hard. So let's compare what we might do with R and with dplyr. So in this case, what you can see, they actually have a pipe operator, so you'll be familiar with that. They put it at the end of the line, so that might be a little bit confusing if you're coming from Elixir. But you can see that we've got this kind of like sentence that's being spelled out almost, right? So we're going to take the data frame, we're going to select some columns, we're going to filter the data, we're going to group it by a field, and then we're going to summarize it based on that grouping, right? Really simple. You can see it. It's right there in front of you, right? And I found that really appealing. I know that the pipe operator makes you think, okay, I'm piping data from this function to this function to this function, and I'm doing something to it at each step. Whereas if we go back, the order of operations is not as clear here. You've got a filter that's happening, with the brackets after the data frame, where you're checking that sepal length is less than 5. Then you're using filter, but filter actually filters columns. Then you're doing a group by, and you have to specify that you're using the by argument for some reason. And then you're doing an aggregation, and you're saying which aggregation you're doing for each column, and that has to be a map. So you're giving it a map of aggregations. I find that really confusing. And I find this really intuitive. And I have nothing else that I can say beyond that. It's something that we then emulate with Explorer. So you can see this is some Explorer code. So we take a data frame, we pipe it into the select function and select the columns that we want. We pipe it into the filter function, and we've got sepal length is less than 5.0. We pipe it into the group by and group by species, and then we summarize it. And each of those keyword list arguments in summarize is matching up with a very similar kind of thing here with dplyr, where we're saying these are the new variables or the new columns that you're going to get, and these are the values of those columns that you want to have. So you want to have sepal width is going to be the max of sepal width. And sepal length is going to be the mean of sepal length. So I actually should have had those as max sepal width and mean sepal length, but it doesn't matter. Those are just names. And that API, that way of working with summarize, also works with other functions like mutate, which we'll see a little bit later. It's consistent and it's predictable, and you know what you're getting. So to talk about those verbs again, really quickly. So when we're talking about verbs, we're talking about they're actually SQL-like, right? And this is the idea. So we work with select for picking columns, and discard to discard them. You can also negative select, but discard's a little bit more friendly. There's filter for picking the rows based on predicates, right? So Boolean predicates, effectively. We had the Boolean operator, the less than operator in the last slide. You can mutate, so you can add or replace columns that are functions of existing columns. You can use sort by, so you can change the ordering of the rows, right? You can choose unique rows with distinct. You can summarize. If you've got groups, you can basically grouping multiple rows down to a single summary row. And you can pivot. So these are some of the things that are actually picked up with tidyr in the tidyverse. You can do pivot longer and pivot wider for kind of manipulating some of those situations, like when we have column names that are actually values. You can use pivot longer to pull them down and kind of push things into a tidy data format. And you also can combine all of these with group by, which operates on groups, right? And then those are the single table verbs. Those are typically if you're working with one, but then we have multiple table verbs, which are mostly around joining, right? But we can also stack them horizontally or vertically. So you can stack them on top of each other or next to each other. And we have a bunch of SQL-like joins. So we actually have, inner, left, right. There's Cartesian joins, outer joins, all that good stuff. And then we have some things that are driven by the row index here. So we've got you can get head, tail, slice for slicing row indices and stuff, and samples. So sampling the data frame by row. These are all your kind of bread and butter stuff. You often will want to just look at the head of your data set and have a look at what's going on there, right? And then what's really, really, really important, I think, is that Explorer is Elixir-ish, right? So saying before how pandas doesn't feel very Pythonic. And actually, I don't think dplyr and the tidyverse is super R-ish either. It's become the standard, and it's so widely adopted that people basically do everything in dplyr and in the tidyverse now. But it doesn't actually utilize a lot of the base constructs of the language. The language is actually a wild language. It's R is like the great troll of all languages. It's object-oriented and functional at the same time, and it's got all sorts of stuff going on. And there are 8 different object classes. It's wild. But you can see what they do is they try to make it easy to type what you want to do, right? So they make it easy to write things in a natural way so that you can work with your data more quickly and intuitively, right? You can see here where in base R, you've got this like the cash sign or dollar sign operator that accesses the variable. And then below here, you can make it more concise, right? Because you can actually just have like a completely unbounded, unquoted string here, right? And we take a little bit of an influence from that in Explorer, but it's part of what makes it a little bit tough to work with things when they start to get a little bit complicated in R. So there's actually a DSL around tidy selection, it's called, and you have to learn this DSL if you want to work in the tidyverse. And it's not base R. It's actually quite convoluted, and if you want to start to unpick it, there are a lot of assumptions and things that you have to work around. It can make it quite challenging. When you get the hang of it, it's not that bad. And it makes most day-to-day operations easier, which is, they made a good trade-off, I think. But it's not just R, right? And with Explorer, one of the things that we really wanted to do was to make it basically as much like just working in regular Elixir as possible, even though we're building on top of a Rust library and calling in Rustler functions, and even though we're doing a lot of like manipulations and data frames and series are actually macros. They don't have to be. You don't have to use the macros, but they're opt-in and they make things a little bit nicer. So Jose Valim actually made this module called Explorer Query, which are the macros that kind of power Explorer. And I think that this is one of the really exciting parts of Explorer, is that if you're coming from an Elixir background and you like working with Elixir, there are a lot of things that feel really natural. So yeah, we're gonna pull in a macros here, and it's going to not just be pure Elixir, but I think it's going to feel quite natural to you. So you basically can do things like we saw in that R example, where you can call the nums column and you can filter the data frame by nums. Oh, hold on, let me go back there. Sorry, I clicked nums that are greater than 2, right? So we're going to filter it out and we'll get that one column here. One thing you're going to notice as we go through is that the Explorer data frame struct looks like this. It's actually very similar to Inex, and that was a purposeful decision. There's a library that allows peeking. It's called data peeking in R that we kind of took here, but it's basically not a tabular representation. It's actually more of like a stacked representation. It lets you see a little bit more in like a terminal. Yeah, if you want to access variables, you kind of do the same thing that you would do in Ecto, where you can pin them, and you can get access to actual Elixir constructs. You can use the pin variable, or sorry, the pin operator. And what I think is really cool is that you can use your conditionals the same way as you would in regular Elixir code in Explorer. So you've got this kind of like, you can do a con statement here. And those are the names of columns. So you can say con do when A is greater than 9, we're going to do exceptional. If it's greater than 5, we're going to do passed. And if it's true, we're going to say failed. And what you're going to see is that we've got this table now where A has the values that we had before and B has the corresponding kind of conditional statements that we got there. And there's also some much more powerful stuff. So there's across and comprehensions. So you can use mutate, as I showed you before, and you could just write out mutate, but you can see that it starts to get really repetitive. We've got sepal width minus the mean of sepal width divided by the variance of sepal width. So for each of these, we were wanting to calculate each of those, and it's all going to be the same, right? We can actually use for comprehensions, which are one of my favorite parts of Elixir. And so you can say, for the column name across these columns, you can do this. And so in this case, we're going to say we want to do, column minus the mean of the column divided by the variance of the column. And you end up being able to calculate and get the exact same thing. And you can pass in a lot of stuff, basically. You can pass in effectively enumerables, right? So it's lists of column indices or names as atoms and strings, a range or a regular expression that actually only matches the column names that are part of that regular expression. And yeah, in that example, we kind of like, we knew the width and the length of the columns for the first four. We can make it even smaller. We could just write across 0 to 3 and just take those indices, or we could take a regular expression and just grab the, you know, if it starts with sepal or petal underscore ends with length or width, then we're going to do it here. And it's just this down here. That's this pattern generator filter expression. That's exactly the same as regular Elixir for comprehensions. You just get a bit of magic. And yeah, you can kind of see that we can do comprehension filters as well. So same way that you can do with for comprehensions in regular Elixir, you can say like, I'll do for across, that's across everything. And then you can write a filter here, like a conditional, where you say like for call across where call, and we grab the data type. So the D type only matches these floats, 64-bit floats, right? That's another cool way of going at this, but I think it's really powerful. It jives with actual Elixir, and I kind of wanted that to always be the kind of guiding light. So last thing I'll say is that Explorer is last mile transport. When I was first coming up with the idea of doing this, or when I first saw that that Jose and Sean were working on the NX project and kind of heard about all of this and knew that there was going to be numerical Elixir, one of the things that I immediately kind of jumped in and kind of complained about on the message board, and was like, there has to be a data frames library. You have to be able to do it. And the reason is that the thing that I think about when I think about data frames is last mile transport. So I think about high speed rail, for example. You can go to a country like the United States that has really poor public transport, right? And you can build high speed rail between two cities that have bad public transport. So let's say you do it in Florida, where I'm from, which has basically no public transport, and you build the high-speed rail between Orlando and Tampa. Think about that high-speed rail as your deep learning algorithm. You can build this awesome deep learning algorithm, and you can build this awesome model. But if you can't get from your home to the starting line, or from the end of that to where your destination is in the end, then it's effectively useless, and you're going to have to use cars in between anyway, right? And that's how I think about Explorer. Explorer is all that work that you need to do to get to the train station, and then to get to where you're going from the destination train station. Let's see here, I'm clicking through. And so
yeah, that's
going
a great
back
way to think about it.
Oh, thanks. And going back to that diagram that I showed you before, we can kind of see how some of the ecosystem that exists now maps onto this. So Explorer gets you that import and tidy and transform steps. VegaLite gives you visualize. There's also Toucan, which is higher level on top of VegaLite. Axon and Scholar give you models, and then livebook allows you to communicate. So we've got this really excellent kind of ecosystem now. And it also does more. So Explorer is not, I think, just for use in these kind of typical data science situations. I'm actually going to be giving a talk later this year at ElixirConf on how data frames are not just for data scientists. And this kind of shows that, I think. So yeah, it's plots, but it's plots for an end user, pretty high level, not really data sciencey. Here's just a little video from our application. We're showing basically a result set, and we're breaking it down by the assignees, which are the people who own the rights over the patent, and by clusters. We've assigned some clustering to the patents to determine which ones are most similar to each other, and we're then showing that over time. So the publish date, like year on year, and showing kind of the count in each year. And all of those pivots. Yeah, go for it.
I'll ask you here: is this are these VegaLite plots on top of a Explorer data frame, and then it's all rendered in LiveView?
That's exactly right. And I'm actually going to show you guys quickly in a moment. So it's yeah, that's exactly right. And so one of the things that I think is, oh, that's the last slide here. Let me go back to playing on there. One of the things that I think is kind of overlooked is just how well Explorer and how data frames can work in this kind of like web-based flow. So if you're working with something like VegaLite and you want to do those kind of manipulations, you want to split it, you want to start like chopping and changing and pivoting and stuff like that, typically what you have to do is send all of your data to the browser to allow it to do that. And when you're working with quite aggregated data, so in this case, we're just looking at counts, right? The counts are very, very small. Like counts by year by assignee are much smaller than one row per assignee per patent per year, right? We're talking orders of magnitude smaller. So, or an order of magnitude smaller. And so you don't want to necessarily send all of that data up to the front. And so I'm going to switch the screen that I'm presenting here. Let's see if you guys can see this. You got it?
Yep. Yep. Looks promising.
Okay, let me see if I can make this bigger. Oh, I'm looking at the wrong thing. Hold on. Yeah, okay. Perfect.
Yeah.
Okay, I'm going to make it a bit bigger so you're actually able to see a bit more. There we go. So here's a component, right? It's a live component. We've got an embedded schema, which is, I think, a really great way to work with forms in live view if you're not doing it already. And we build a change set over those forms. And basically, this is the component that you guys just saw. We can see we've got fields for group by, for faceting, and whether or not we're going to have cumulative, and we have a change set for that. You can kind of see the way the render is. It's very, very simple. But what you're going to notice is that it's not just like it's not just the kind of the plot here, right? Like we're building we're building what I would call like small multiples and things like that really, really rapidly using data frames. So we've got this render plot function, and this render plot function is taking assigns, and every time those assigns change, we're actually completely re-rendering the plot. And when we re-render that plot, just going to go to definition here. We're actually just going and calling this construct data frame function. We'll go to that definition, and you can see that we're preparing the data frame here for visualization. The first thing we're doing is we're counting how many documents you have for each year, group by, or facet combination. Then we're expanding that out until to get all the unique combinations so that we can plot it in a uniform way, filling nils with 0, right? We order by year, and then we do a cumulative sum to get the counts, right? So that we count those zeros and everything. We can kind of see the cumulative value. So you can see we're saying we take the map data. The map data, I can just call data frame new. Now, the reason I'm able to do that is because data frame new, it takes advantage of a little known library that's a table protocol. And if it implements the table protocol, then data frame can make it into a data frame. So lists of maps and maps of lists of the same length implement the table protocol. Or now I'm questioning myself whether it's behavior. For some reason I think it's a protocol. But we're able to call data frame new on it, and then we're able to start calling data frame functions. So we mutate it. I do use that conditional that we showed you earlier. So we're just using a really normal if else here, and then we mutate, and we turn the published value into a year. So we're calling a year function, and in fact, this code is a little outdated. Some of these things can now be like, you don't have to call series in front of it if you're calling the macro, because series is already imported into the namespace. We then go and we construction and expansion to try to get all the unique combinations, and then we take that, we group by the published group by and facet fields, unless they're marked as none, because you saw before we could remove those facets, we could remove the group bys. We then summarize down to get the counts. We expand to all the different combinations. So we do an outer join to do that, and then we sort by the published date. We fill the nils as zeros using a mutate. So we call count. We're overriding the count variable there and saying that we want to fill missing. So fill missing values with zeros on that count variable, on the count column. Then we group by. Again, we're gonna call an enum reject here. We want to group by the columns that aren't none, that aren't listed as none. And then we do a cumulative sum. We ungroup them. I'm doing an explicit ungroup there because I did a mutate over the group by instead of a summarize over the group by. So if you summarize, it will automatically or implicitly ungroup. But if you don't summarize, you have to explicitly ungroup. That's the same in dplyr and other places as well. And then I'm calling then with the data frame. If the group by is not none, I'm calling that we want to filter is not nil. And that gives you the data. And we pass that into a Vega Lite spec, and we send that Vega Lite spec up to the front. So what you can see here is that we're doing a ton of work, it looks like, every time you click something. But you can see from the video I showed you that it's super quick, it's super responsive, and it's because those diffs are actually really, really small. The amount of data that we have to send up to the front every time is minimal. And Explorer uses a very fast backend. So each of these rounds of manipulation are, it takes milliseconds every single time. So I think this is a really kind of cool pattern. There's some stuff in the work to try to formalize it actually, but it's a pretty cool pattern. I am going way over time. I actually had a live book as well as promised, but
don't stress about it.
No, we can move on to live book.
Keep going for a while. Yeah.
Sure.
I think anyone who's uncomfortable will drop off when they need to, but I certainly find this interesting. If you can share some of the live book stuff, that would be great.
Yeah, cool. All right, let me go ahead and share that. So I'm gonna go, let's see if I can change where I'm sharing. Go back to the tab. It's going to, I'm gonna get an infinite window probably, but present something else. Oh, I can do a different tab. That's cool. All right. That was easier than I thought. All right. There we go.
Like many things with Livebook and Elixir, ends up being easier than you thought.
Yeah, no, exactly. Cool. So little Livebook here. Basically just kind of got started with it. I wanted to show off a couple of things that are pretty exciting. So I'm going to start by showing you the mix install step here and the things that I've installed. So I've installed Explorer. I've installed Kino explicitly. You don't necessarily have to do it explicitly if you're calling Kino Vega Lite and Kino Explorer. So one thing to note here, and you'll see it in a moment, is that Explorer has its own Kino. It's pretty cool. We'll check it out in a second. I'm also pulling in ADBC. If you're not familiar with that, that's the Arrow version of ODBC or JDBC. It's a database connector for the Arrow data type. And Explorer is able to use that to very efficiently pass data around, so they can actually do effectively zero copy. It doesn't need to deserialize back into Elixir before it then converts it into a data frame. It can do it directly in Rust. It can just pull the data in Rust and never transfer it up to Elixir and convert it into a data frame directly from your database. There's NX, EXLA. EXLA is the kind of backend as well as a compiler for NX that allows things to be accelerated and faster. There's Toucan, which is a higher level plotting library on top of Vega Lite, and Recase, which I'll show you in a second, which is a fun little library for changing things from like camel case to snake case and things like that. I config it. You have to call the driver that you want, the SQLite driver, the SQLite driver. And then NX, you always want to set these default back into EXLA and default FN options to EXLA, and in this case on the host. So there we go. We've got that all set up. I'm just going to go ahead and close it. And we're going to come down here and we're going to bring in the data frame and the series macros. So we're going to require them. I like them to be a little bit longer. I like to write out data frame and series. I'm weird like that. Lots of people will just mark it as DF and S. You can choose what your alias is. And then what we're going to do is we're going to use Kino start child to start the database connectivity, right? So we're going to pull the SQLite driver. I've got a URI that's pointing to a SQLite file, and then I'm going to explicitly set a PID for the connection, so the actual con here. And we're going to work against that when we want to pull data in from SQLite. So here we go. So the first thing I wanted to do is I also wanted to get a sense of what tables are there in this database that I've pulled. So I literally just pulled it today. I know very little about this data set. I just want to understand what's going on. So I do from query. I'm just going to go ahead and run that. So in this case, so we're going to pull from the SQLite master table, and it's going to tell us the different names of the table. So I can see that there's one for businesses, one for inspections, and one for violations. Those are the 3 different tables that I'm going to work with. So cool. And then I'm just going to write some Elixir, right? So I'm going to say, actually, I'm going to make a map of these data frames to begin with. So for the table name in the series 2 lists, so I'm going to iterate over a list version of the names that we just got, the tables data frame. I'm going to access it using the access protocol, and we're going to say name here. I'm going to say into a map. And then we're going to do where the key is the name, the table name, and the value is, I'm going to take that con PID that I grabbed up there. I'm going to pass it into data frame from query. In this case, I'm actually doing something slightly unsafe, which is interpolating the query. It's not a parameterized query, but hey, I'm in my own livebook. I can do what I want. And you can't parameterize the table name anyway. So to make it easier for me, I'm just going to do that. But you can use parameters. I actually just added docs to this today because we didn't have information about the fact that like SQLite uses question mark and Postgres uses like cache 1, cache 2, that kind of thing in the from query. And then I'm going to rename them. I'm going to rename all of those variable or all of those column names with recase to snake case. So I'm just going to go ahead and let's do this. I'm going to comment that out. I'm going to run this. And of course, I need to, sorry. So I'm going to comment that out and run this. And what you're going to see is that we've got 3 different data frames. We've got businesses, we've got inspections, and we've got violations. And you can see in the data structure, you can see that it's using the Polars backend, the number of rows and the number of columns. But what you can see is in these column names that you've got over here, you can see the column name and the type that goes along with them. You can see that some of them are different from others. So like risk category is snake case and violation type ID is, it's not even camel case, is it? It's whatever the other one is. What was that? Sorry. Pascal case. Yes. Yeah, that's the one. And so I'm just going to throw it into snake case, and then they're all standardized, which I find really, really handy. So we've got these different data frames, and we can start to tuck into them. So let's grab businesses. I'm going to call it this data frames businesses. I'm going to grab that value. And you can see the keynote at work here. So the keynote gives you a lot of information. It tells you that we're looking at a data frame, it tells you the number of rows in that data frame. You can choose how many you want to see per page. You can actually do some searching within it. And you can see the number of pages that we've got here and each of the different variables. You can technically...
I just want to check on that search. Is it searching the whole data frame? It's not searching just the visible bit.
I don't know. No, it's the whole thing because it is showing 2 results for tiramisu, and there's only 1 here on the screen. Oh no, there's 2 on the screen, so maybe I'm wrong. I'm not sure. I'd have to check into it.
Okay.
So we've got, you know how I can tell you actually. I'll tell you in a moment. So we've got the different variables. We can see that we've got like a business ID, and you can see the data type up here. You can see that it's a numeric type. This is a string type. You can actually sort based on the different columns as well. So like with the names, I could do a ascending sort, and I can get them all in alphabetical order. And it's super fast because it's actually using Explorer under the hood, which is great. And we've got your address, city, all this kind of information, latitude, longitude, cool, business certificate. Then we got a bunch of stuff prefixed with owner name, owner address, owner city, owner state. And when I see that, I immediately think this is not tidy data. I immediately think that those should be their own table. So we'll deal with that. Let's go ahead and pull that out. And so I'm going to do this a little bit at a time. Sorry, let's do it this way. I'm going to do this a little bit at a time. For some reason, my right click isn't working with livebook today. There we go. So we're just going to have a look and say businesses. Okay, so we've got the businesses table. I'm just going to build it up iteratively. So we're going to select all of the columns where it starts with owner underscore. pretty easy. We can use a basic Elixir function here and just use string starts with, and that's going to be our Boolean determinant of whether we're going to include that or not. So we've done that, and now we've got all the owner columns. So the thing is, so with the owners, I have a feeling that there are some repeats. So I want to go ahead and take distinct owners. I can see that I've got 7,634 entries right now. If I take distinct, it goes down to 7,025. So I definitely did remove some duplicates in there, which is going to tell us that there's some owners that have multiple businesses in this data set. And then I'm going to go ahead and I'm going to rename these. And the thing is, I want to rename everything but the owner name column. I want to leave that column there because that's going to end up being our join column to businesses in a little bit. Or sorry, back to businesses in a bit. So I'm going to just use a regular function with multiple function heads here, an anonymous function. It's owner name, then I'm going to go ahead and keep the name. And if it starts with, otherwise, if it starts with owner underscore, then I'm just going to pull the rest of it. So we'll do that. We've got owner name, address, city, state, zip, all that good stuff. So we've got a data table there. Now I need to build like a join table. And to do that, I'm going to join the business ID and the owner name here. I'm going to pull those from the business's data frame. And that's going to give me all of the combinations of businesses and owners, and I can go and use that later. I was curious after that to find out who has the most, right? So I want to go and find the largest owners. And to do that, I'm going to go and take that business owners data frame that I just grabbed, and I am going to group by the owner name. So now I've got, and you can actually see that this is grouped here, whereas over here you can see that it's not grouped, right? So this is the column that we've grouped by. That I'm going to summarize by the size. One little gotcha here is that series count counts the non-null values, and series size counts all null and non-nulls. So it's worth using size when you want to count rows, basically. And then I'm just going to sort by, in descending order, the business count. And so you can see here, this volume services America has 94. There are definitely a few repeats. And if I was going to go through and really clean up this data set, I would see, oh, there's 3 different entries for Walgreens. You know, volume services America has another entry here. And so they actually own more. But for the purposes of just tonight, I don't think we need to go super into that and do some cleaning up. But yeah, you can go and compare those and tidy that up. So I'm going to then go and strip out the owner fields in the businesses table and just have businesses without any of the owner fields. And now I've got my businesses table. Inspections, I want to have a quick look at that. Hold on here, let me just make sure. Yeah. So inspections, I'm going to have a look at that table. This shows me I've got the business ID, which is going to allow me to join. I've got a score, which is the score they get on the inspection, the date, but you can see that this date is actually just a string column. And then I've got a type, which is telling me the different types of the inspections, right? And I've got a very similar kind of thing for violation. So violation joins on the business ID. I've got date, but again, the date hasn't converted into a date type properly. I've got violation, risk category, and a description of those violations. So what I'm going to do is I'm going to take the inspections and I'm going to mutate it. I'm going to take the inspections table. I'm going to cast the business ID to an integer, because if you notice here, it's a string. And I want to be able to join against the business IDs that we had before, and the business IDs are integers. So that one's a string, so we're going to cast it to an integer. We're going to take the date. We're going to do a strip time. We're going to say year, month, date, and then cast it to date. We can just pipe through just like normal, even though we're in a macro and all that. And then type, I'm going to cast into a category because I want to be able to use it as a category rather than just as a string. And so you can see now we've got these nicely formatted dates. We've got the business ID, all that good stuff. And I'm going to do basically the same thing with violations. I'm just going to move through here so that we can get through. So if I just wanted to count by the risk category. So we saw before that there were these risk categories in the violations, right? There's 3 different unique values we can see. There's moderate risk, low risk, and high risk. We could go and if we wanted to do series distinct, we could do violations and then grab the risk category. I can't type, sorry. And we could see those unique types there. So you can always go and interrogate your data and do all that good stuff. But if I want to count by risk category, I'm going to group by the business ID and the risk category and violations, get a count of each risk category for each business. And then I'm going to summarize basically just on the count of that. So we can see, the different business IDs and their different moderate, low, and high risk violations. And then we can count those as well using Toucan. So I'm using Toucan to do a single line bar plot here. I'm taking that data frame that I just had, and I'm saying that I want to have a bar plot with it. The field that I want to use is the risk category, which is what we split this by. And the value is the count. And it actually is summing that for me. I set the width and the height just so we can see it a little bit bigger. And you can see the low risk is the most common one here. Kind of unexpected, or kind of expected. So not really anything surprising. We can move over to doing something interesting, like we can manipulate and engineer some variables here. So let's say that I thought that you could have a weighted score for each business based on the number of violations they had, weighted by how serious it was. So I'm going to kind of show off that con statement that I had before, where I'm going to mutate and say I've got a weighted score where the risk category is high risk, it's ×3. The risk category is moderate risk, is ×2. Low risk is ×1. Then I'm going to group by the business ID, and I'm going to summarize by summing those weighted scores. And I'm going to get the total here is total number of violations. So I might even want to rename that and say total violations. We've got total violations, weighted score. And then what we can do is we can actually plot them against each other. So we could say, hold on, I have to do, what's that, total violations, right? So I can just really quickly say, all right, I want to join that against the business name and the business owners and the largest owners. You'll see why in a second. And sort by the weighted score. That's, we can work through it and kind of see what those different ones are. But you can see this, we've got a plot here, and you can actually add a tooltip and in your live book, go and look at this data. Now, the reason why I went and grabbed the business owners and the largest owners is because I can actually do a bubble plot, which I thought was interesting. And I'm going to do that by, let me see if I can remember what the variable name was. We'll pull this, and we've got business ID, weighted ID. Hold on. So we joined up and we got the business count here. So I'm going to do the size of the marks with business count. And what emerges is that you can see that the ones who own the most actually are kind of the safest and the least violating businesses. So if we've got the weighted score here along the bottom and the total violations here along the y-axis, then you can see that we've got some that are way up here, right? Like I can't even mouse over them. I can zoom in a little bit maybe, but you can kind of see some of these businesses up here are ones that you would not want to visit, right? They've got a great deal of total violations. They've got a really high weighted score. So they're doing a lot of serious violations and stuff. And then down here, you see some of these ones are much safer. They don't have many violations. And it seems to be the ones who have, that are larger businesses or have more of the restaurants that have fewer violations and less serious ones. Last thing I'll do, because we've gone quite over time, is just to point out one last cool thing about zero copy, which is that we have built this such that that we can do zero copy transfers from data frames to NX tensors. So if you have NX as an optional dependency, then you can do series to tensor. You can actually do data frame to tensor if they're all of the same type. And if you use series to tensor, you end up with these NX tensors. And what's cool about this is that we've, again, utilized the serialization and deserialization of Arrow on the NIF side as opposed to on the Elixir side, so that we don't have to deserialize the tensor into Elixir and then convert that, or sorry, deserialize the column into Elixir and then deserialize that into a tensor. We actually can pass that data back and forth and operate almost directly on tensors. So basically what has happened here is that there's an NX container protocol, and it is implemented by, again, is it a protocol or a behavior? I think it's a behavior, NX container behavior, and it is implemented by there's a next container behavior that's implemented by series. So we can get these tensors. I then use defn to define, oh, hold on, total violations. Sorry, I renamed it above and then ruined everything going forward. And you can see that those immediately change into tensors. I've written a little Pearson correlation. I mean, you expect these things to correlate, right? The weighted score and the actual score. But then we can run that through NX functions, basically, really, really simply. And we don't even, it's all just kind of there. And I think, let's see how brave I am. I think we should be able to just do this because it implements I may have to do a 2 tensor. I'm not sure. Let's see. Nope, it worked directly. So by implementing that behavior, we can just literally call it directly in defn functions. We can call those series directly there without actually doing the series 2 tensor. So yeah, that's kind of as far as I got with livebook.
That was fantastic. Thanks a lot.
Thanks. A lot of information, I know.
Yeah. I feel like it's one of those talks that I'm going to probably rewatch a few times to grok everything, but I've certainly got a lot of stuff now that I haven't gotten before. So thanks a lot for sharing that. Yeah, it's really useful to see you go through it in livebook as well. It's really fast to just quickly make sense of a data set and try new things and explore new directions that you didn't see coming. It's fantastic for that. Yeah,
definitely.
Anyone else with a question or a comment for Christopher before we wrap up?
No, just comments. Thank you very much, Chris.
Certainly
great stuff there, especially of how you relate the data comes in up until you start analyzing the data within the same runtime. You've been using it quite.
I have to say, the audio is not great. I'm really struggling to hear you. I'm sorry.
No problem.
Oh, that's way better.
Presentation definitely something for good safe and yeah.
Oh, thanks.
Cool. Anything from anyone else? Cool.
The Java guy.
Cool. Yeah, then thanks a lot for taking time off from family as well. I know you've got a wife and a child and a cat.
Yes.
So thanks for sparing some of your evening. We really appreciate it, and I think it's going to definitely make a difference in some of the work that I do going forward, having a better understanding of how these things fit together. So thanks a lot for that.
Great.
Cool. Hope to see you.